Welcome back, you guys. Today we are going to work on the average rate of change. This is Math 3, Term 3. The great news about the average rate of change is that it's just like slope. So if you remember slope from Math 1, awesome. If you don't, we're going to review it, don't worry. So I have my lesson in front of me. I always have a notepad just in case, and I always have a calculator just in case. So let's get started. Average rate of change. Here is a very complicated way to say that the average rate of change is simply the rise over the run, but also not specific, not just the rise over the run, but more specifically, we can also write it as y2 minus y1 over x2 minus x1. That is going to be the average rate of change formula. Now, the reason you're probably wondering, Meryl, why is it called average rate of change if it's just like slope? Well, slope is the rate of which a straight line is increasing or decreasing, okay? A straight line. But in Math 3, you've noticed that you don't always deal with lines. We barely deal with lines. We have quadratics, we have rationals, we have logarithmic, we have radicals. We have a ton of new different functions we've been working with that are not straight lines. And we still need to find the rate at which the graph is changing between 2 points that are not on a straight line. So basically it is the slope between 2 points not on a straight line, aka average rate of change. All right, so let's go ahead and take a look at an example. So this one right here, find the average rate of change on the interval 0, 2. So all that this means is this is the x value 0 and this is the x value 2. That's all it means on the interval 0, 2. So what you need to do first is you need to find the coordinate point when x equals 0 and when x equals 2. So when x equals 0, the y value is 1. Oh, sorry. Whoa, holy cow. The y value equals 1 based on the graph. And then when the x value is 2, the y value equals 2. So that's the first thing, is you want to make sure that you're finding the coordinate points to plug into the formula. Okay, so if I were to plug this into the formula, let's rewrite the formula here, y2 minus y1 over x2 minus x1. The only reason we have these little subscripts, the 2's and the 1's, are to tell you that these two come from the same coordinate point. Okay, these two come from the same coordinate point. That's it. That's the only reason they have those. Okay, so which tells me if I put 1 here as my y value, then I'm gonna have to put the x value right below it from the same coordinate point. Okay, then I have the same thing with the 2's. And then I'm subtracting. Now, a little trick that I do, you guys, is whenever I'm doing these, I immediately do a line minus minus so that I don't screw up my pluses and minuses, okay? Then I put one coordinate point x, y, and the other one x, y to set it up. Then I solve. 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative divided by negative is a positive. So positive 1/2 is going to be your average rate of change. If you were doing this on the quiz, you would enter it as 0.5. Okay? And that's how you can do it using the equation. Another way you can do it is you can remember what you did in Math 1, rise over run. So I'm always going to rise first. So I'm going to start from the left point and I'm going to rise. So I rose positive 1 over the run. And because I'm going to the right, that's going to count positive. So 1, 2. So positive 1 over positive 2 is 1/2. If I were going down for my rise, that would be negative. If I were going to the left for my run, that would be negative. Then you would get, so let's do it from this coordinate point to the other one. So rise would be down 1, so negative 1 over a run, which is left 2 Negative divided by a negative is a positive. So you can see there are multiple ways you can do it. Let's go ahead and look at an example on a table. So find the average rate of change on the interval 1, 3. Once again, the 1 and the 3 just mean the x values. So I'm going to be looking at that coordinate point because the x value is a 1, and that coordinate point because the x value is a 3. In this case, you can't just count on the graph because there is no graph. So what we're going to do is we're going to do the y2 minus y1 over x2 minus x1. I always do line minus minus. I take one coordinate point, x on the bottom, y on the top. The other coordinate point, x on the bottom, the y on the top. Does it matter if I did the 372 first and the 118 first? No, it doesn't matter as long as these on top of each other come from the same coordinate point. So now I'm going to do 18 minus 72 on the top. That gives me negative 54 over 1 minus 3 is negative 2. And negative divided by a negative is a positive. This is going to give me 54 divided by 2 is 27. So that is going to be my average rate of change. So let's just do one more for good measure. Let's do one from the quiz. On the following cube root, find the average rate of change on the interval negative 8, 1. So negative 8, here's the coordinate point, and 1, here's the coordinate point. So I can do this two ways. I can do by finding the coordinate point. So let's do it that way first. Let me make some room here. So I have negative 8 and I have 1, and I need to find the y values associated with them. So at negative 8, the y value is negative 6, and at 1, the y value is 3. I have my line minus minus. I put the x value on the bottom and the y value on the top. X value on the bottom and the y value on the top. So then I have negative 6 minus 3 is negative 9. Negative 8 minus 1 is negative 9. Negative 9 over negative 9 is just 1. So my average rate of change should just be 1. I can double check it by just looking at the graph and counting. So I'm going to start at one point and count rise over run. So my rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. Over my run, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 over 9, which is 1. So I'm going to enter that in as just a 1. Now, if this were a decimal, I would want to make sure I read the instructions. It says round to 1 decimal place. So I want to make sure I round correctly. But since this doesn't have a decimal, you don't need to round. Hopefully that helps you guys. Hopefully you paused, took notes, rewound if you needed to do so, and ask me if you have any questions. Keep it up. Great job.